All right, so I'm going to try doing this geometry review again, this time with better audio. I'm going to cover as much as I can in this first section. I've got about an hour or so to do this.
Pardon the interruption. Alex Oder, if you were in the...
Okay, so with question number 1, and hopefully even if you watch the first video with the terrible audio that sounds like I'm trying to teach the lesson out of a pool of water, you should still have seen a lot of this work already take place. So the first thing we're going to do with question like number 1 is that we need to find the midpoints of each of the line segments. In order to do that, we're going to use the midpoint formula. But before I can use the midpoint formula, I actually need the x and y coordinates of each of the 3 points. So I need to know that this is -3, 0. I need to know that this is 1, 2. I need to know that this, that C over here is 5, 1. And then I need to know that the midpoint formula is going to use those x coordinates and the y coordinates to set up x sub 1 plus x sub 2 divided by 2, and y sub 1 plus y sub 2 divided by 2 in order to find these. So if I was doing this, granted it's been shown in a different video, you could go and you could look at the other one. But if I want to find the distance or find the midpoint between A and B, I'm going to take the x coordinates. So hopefully you can hear me this time. But I'm going to take -3 plus 1 and divide that by 2. I'm going to take this x1 plus x sub 2 in this case. -3 plus 1 is going to be -2, and I'm going to divide that by 2, and I'm going to get an x coordinate of -1. Okay. Then I'm going to take 0, my y sub 1 and my y sub 2. And I'm going to take 0 plus 0 plus 2 and divide by 2. Well, 0 plus 2 is 2. 2 divided by 2 is 1. So that midpoint coordinate comes out to -1, 1. And that's my midpoint. And I'm going to make my mid-segment there, or my median of my triangle is going to go across to the opposite vertex. Then I'm going to do that with a different set of coordinates. Okay, so from, let's say, B to C. So I would be doing 1 plus 5 divided by 2 would give me my x's. Okay, 1 plus 5 is 6. 6 divided by 2 is 3. Okay, so I'm getting a 3 out of that. 2 plus 1 is 3. 3 divided by 2 is, let's see, 3 divided by 2 is 1.5. Okay, so 1 and 1/2 here, okay, is those coordinates. So I'm looking at 3, and I'm going up to about right there, and I should see, again, my line's not very, it's not a great line, but you get where we're coming from. Okay, and then finally, I want between A and C, so I'm going to take -3 plus 5, which is going to be 2. 2 divided by 2 is 1. Okay, and then 0 plus 1, okay, is 1. 1 divided by 2 is 1/2. So I'm getting this 1 going up half. So I should see this. And that point right there, okay, is my centroid. And that's what they're asking for. You could look at all the baker's bread stuff, but that's not really going to get you where you want to go. If they're asking if it's balanced, that means it's going to be an equal distance from all 3 vertices. So that's what we're going to get for that. Okay. All right, and if you want to know numbers, that's lesson 32, altitudes and medians of triangles. Okay. Question number 2. Let's see if I can do this without it going just crazy. A community building is a square park. So let's start off by drawing a square park over here, kind of out of the way. Square park, okay, means that all 4 sides are the same length, all 4 angles are right angles. Sides measure 130, they tell me. Okay, so 130, 130 to separate the area. They have a diagonal line from opposite corners. So I can go from here to there. Determine the approximate length of the diagonal line that splits the square around your answer to the nearest tenth. You might be able to see here that this is a right triangle that's being split. I can solve, if you'll notice, that if I make this diagonal line a red line, that red line right there is the hypotenuse of that triangle. So I could use the Pythagorean theorem and say that 130 squared plus 130 squared, okay, equals c squared, and I could solve that. Or I could see that a square is also a rhombus, and my rules of a rhombus tell me that diagonals bisect opposite angles. So if that was 90 degrees to begin with here, I'm going to divide that by 2, and I'm going to wind up with a 45, 45, 90 triangle, in which case I know that my ratios are x to x radical 2. So if it's 130, it's going to be side length, it's going to be 130, 130, 130 radical 2. Either way that I do this, either way is fine. I can show you that you're going to get the same answer no matter what you do if you do it correctly. So in one case where I have the square root of 130 squared plus 130 squared, okay, I'm going to get, looks like 183.8. They want our answer rounded to the nearest tenth, so 130.8, you could even maybe make a case for 183.9. Or I got 130 times radical 2. You see that I get the exact same answer. So there's more than one way to find the length of that diagonal line. So I hope that that helps you out. Question number 2, that comes from lesson 33. Okay. Let's see, number 3. Let's see, we're looking at a parallelogram here. We have 4 rules of a parallelogram. I'll read those off to you, but you really would want to go back to lesson number 34, properties of parallelograms. Look at your notes. You've got these written down, so I'm not going to write them down for you again. But in that, we know the opposite sides are congruent. So segment ST is opposite to segment RU. Segment SR is opposite to segment TU. Those opposite sides are going to be congruent to each other. Opposite angles are congruent. So angle R is congruent to angle T. Angle S is congruent to angle U. We also know that consecutive angles are complementary. Complementary meaning that they add up, or sorry, not complementary, but supplementary. So angle S plus angle T adds up to 180. Okay, T plus U equals 180. R plus U equals 180. S plus R equals 180. The only things that won't work there are S to U or R to T. Okay, so we're using that information. So whenever we put in our labels and they tell me that UR is 25, I'm going to state that segment ST equals 25 because, and so listen to me closely, if you see this question on a test, I would write next to this, because opposite sides of a parallelogram are congruent. Okay, so I know that this is 25. Okay, the other thing that we know about parallelograms is that the diagonals bisect each other. Okay, so SU is going to cut RT into 2 congruent segments. That's going to be important because what they're going to show me here is that RX is 16, which means if it cuts it into 2 congruent segments, I know that XT equals 16, and I'm going to say because diagonals of a parallelogram bisect each other, okay, or divide into 2 congruent segments. And then angle RST, measure angle RST is the only one where I actually kind of have to show some math because they tell me that STU, right here, STU is 42.4, and they are looking for RST, which is this angle, that whole angle right there. And like I said before, consecutive angles are supplementary. So the math that I need to show there is 180 minus 42.4, which is going to come out to 137.6. And I can state in this, okay, probably I would accept if you just showed me the math, right? If you showed me 180 minus 42.4 degrees, okay, equals 137.6 degrees, that's enough for me, okay? So explanations on the first 2 parts, and then just the math for the third part. And I think I already gave you the lesson numbers, but that's lesson 34. Okay, question number 4. Okay, coming back up here, area of a sector. So this requires a formula. It's based upon the area of an entire circle. So area of an entire circle is pi r squared. We only want a fraction of that circle. that fraction of it right there. So the rest of our equation is measure of my arc over 360 degrees. They want our answer in terms of pi, so I actually don't have to plug in pi to the calculator or substitute in for pi. What we're going to end up here is we've got pi, we've got r, which is 4 squared, and in my measure, 54 over 360. And because I don't need the pi to answer the question, we are just going to do 4 squared times 54 divided by 360. And that's going to give me, 54, and that's where my mistake was. 54 divided by 360. So you want to be careful in how you plug in your calculator. Your calculator won't give you the right answer unless you give it the right numbers. It comes out to 2.4 pi, because we're solving in terms of pi, centimeters squared. Okay, and that's our work on that question. Okay. All right. Number 5. Number 5, they're looking for the correct statement to begin with, the correct congruency statement. So they're going to start off with triangle ABC. They're going to want to know what corresponds to it. Okay, is congruent to triangle what? Well, A is a right angle, J is a right angle. So that's a good place to start from. The rest of it is helpful based upon appearance. Notice that there's no tick marks between A and B. So K is going to correspond to B, and L is going to correspond to C. Now, for this, because it is a right triangle, right triangles have their own congruency postulates. You'll find them in lesson 36, right triangle congruence theorems. And so here what I'm saying is that BC is a hypotenuse. Okay, it's opposite the right angle. KL is a hypotenuse opposite the right angle. And AC is a leg of that triangle, and so is JL. So what I have is the hypotenuse leg congruency theorem. So that's what I want. Side angle side won't work there. Angle side angle won't work there. So make sure that you are identifying right triangles and using the congruency postulates that go with them, that don't necessarily go with any other type of triangle. All right, number 6. Number 6 requires us to first look and see what type of lines we're trying to compare or show which lines are parallel. In parallel lines, they have a relationship with slopes. In parallel lines in slope-intercept form have the same slope. We can tell right off the bat, lines 1 and lines 3 are already in slope-intercept form, and they're not parallel to each other. One has a slope of -8, and the other one has a slope of 6. Okay, or -8 over 1, and the other one is up 6 over 1. All right, but what we do need to do is convert line 2 and line 4 to slope-intercept form. So let's do that with line 2. We got -1/6 y. Let's subtract x to the other side because we're going to try to isolate y. -x minus 4. Okay, and then we need to multiply by -6. Okay. All right, so we're going to multiply, because we can't divide by -1/6, but we can multiply by the reciprocal. So we're going to multiply by -6 over 1. Okay, we're going to multiply this by -6. So what we're going to get is that these cancel, leaving me with y, and I'm going to wind up with 6x, because we're going to distribute, and -6 times -4 comes out to a positive 24. And you'll notice that line 2 and line 3 share the same 6x slope, so those are going to be parallel to each other. Now you may have to solve number 4 as well, if you have an option where it says maybe lines 2 and 3 are parallel and lines 1 and 4 are parallel as part of one answer. We would want to make sure that line 4 was in fact parallel to line 1. So let's see that. Okay, now we know these. We got y minus 3, and let's go ahead and distribute that -1/8. So we got -1/8 x, and -1/8 times -8 should be positive 1. Positive 1. Okay, if I've got that right, hopefully I do. And then we're going to add 3. Add 3, so y equals negative 1/8 x plus 4. So we're looking at this slope and this slope. Not only are they not parallel, but they're not even perpendicular because they're both negative. So there is no relationship, there's no special relationship between 1 and 4. Okay, so we're just looking at this and saying lines 2 and 3 are parallel because they have the same slope. And I'm going to show those slopes are similar, okay, by converting everything over to slope-intercept form. Question number 2, tell whether the side lengths 3, 4, and 8 form a triangle. This comes from lesson number 39, inequalities in a triangle. And what you learn in that is that the sum of any two sides of a triangle have to be greater than the length of the third side. So we're going to look at that. We're going to say, well, 3 plus 4. Okay, 3 plus 4 equals 7. Well, 7 has to be greater than 8 for this to be a triangle. And because it is not greater than 8, this cannot form a triangle. Now, you could check the others. You're going to see that 8 plus 4 is greater than 3. 8 plus 4 is greater than 3. Or 8 plus 3 is greater than 4, but 3 plus 4 is not greater than 8. So I can't make a triangle out of this, at least not where the endpoints of each length is going to come and touch each other. You're going to have an overlap or something. So if you broke, let's say that you took some sticks, you measured them out to 3 centimeters, 4 centimeters, and 8 centimeters, you couldn't get them to form a perfect triangle. Okay, so our answer to that is going to be no, but we're going to show why. Okay, not just the word no. I won't accept that. Okay, I want you to show me why. Okay, number 8, we're looking for the area of a shaded region. In order to do that, we need to find the area of the entire region and subtract out the area of the unshaded region to find out what is left. What I have here is I have a rectangle, and that's the area of the whole region. And the area of a rectangle is found by length times width. The length here is 6, the width is 5. So we're going to get 6 times 5 equals 30. Okay? And we're going to want to subtract out of that the area of the unshaded region. The first thing that we need to identify is what is the shape of the unshaded region? Well, it is half of a circle. And so if we wanted to find the area of a circle, we would simply divide it by 2 to find the area of a semicircle. But we need to know how to find the area of a semicircle. Well, that's going to be the area of a circle divided by 2 or times 1/2. In this case, the radius is half the width. So if the whole width there, the diameter is 5, then the radius is 2.5. So we got pi times 2.5 squared divided by 2. So we're going to want to know what that is. Ultimately, we are taking 30 minus pi times 2.5 squared divided by 2. So we could do this a couple different ways. We could break it up. We could find out just what pi times 2.5 squared divided by 2 is and subtract that from 30. Or we can try to do it all at once, in which case we need to be very careful so that our calculator knows exactly what we want it to do. That's done by splitting things up. So 3 minus, and I'm going to do 2 sets of parentheses so that I can separate my numerator from my denominator. So I've got my pi, 2.5 squared, and I'm going to divide that by 2, and that way I have my numerator over my denominator, and I am subtracting that whole thing, and I'm going to get 20.18, but it says round it to the nearest tenth, so that's why I'm going to make this 20.2, because it's an area of the shaded region. This is in inches squared. Okay, so that's the work I need to show. You could also find, I think with this, if you just wanted to try this, we got pi 2.5 squared divided by 2. It's going to give you that 9.817. So if we took 30 minus 9.817, we're still getting pretty much that 20.2. So you could do it that same way. All right. Let's come down to number 9. Let's see. Number 9 comes from lesson 42, finding distance from a point less than 41, ratios, proportions, and similarity. What we're seeing in number 9, they're telling me right in my description that these two triangles are similar. Two shapes that are similar will have angles that are congruent and sides that are proportional. So it's really a matter of just setting up the correct proportion. I can set this up as big triangle, 13, over little triangle, 6.5, is congruent to big triangle, 15, over unknown portion of the corresponding side length of the little triangle over x. From here, I just cross multiply and divide. 6.5 times 15, 6.5 times 15 divided by 13. I should get 7.5, and 7.5 is it. They say S, but it's really just question equals 7.5. I don't think there's an S there. It just says find xy. You could write xy equals 7.5, and that'll work. You just want to make sure that you're picking corresponding side lengths, okay, and comparing them to each other. Okay, let's come up to 10. Okay, this is one I was referring to earlier, lesson 42, finding distance from a point to a line. This is easier done whenever I have a vertical line and a point not on that line, because the shortest distance between a line and a point not on that line is a perpendicular line. Because this line is vertical, a perpendicular line to it is going to be horizontal, which makes it really easy to count how far away it is. You could also look at the distance between the x values. Okay, so, or we could say, okay, well, this is 2, 3, and you'd be finding the distance between negative 3, 3 and 2, 3. You could show your work that way. Okay, if I'm going to do that, then really it's just a matter of using my coordinates, plugging them into the distance formula, so that what I'm getting here, is a good way to show our work, is, let's see, negative 3 minus 2 squared plus 3 minus 3 squared. Okay, negative 3 minus 2, okay, is our negative 5. Negative 5 squared is 25. 3 minus 3 is 0. 0 squared is 0. So we wind up with square root of 25. Square root of 25 is 5. And we see that that comes out to the same distance as what we would have counted, but we have work to go with it. Number 11. Number 11 comes from lesson 43, chord, secants, and tangents. Here we need to know, because it's asking to identify the chords, what the definition of a chord is. This would really be part of your answer, that a chord is a line segment whose endpoints are on the circle. So we're looking for endpoints on the circle. So the first one I've got is LH. You could have these in any order. Segment LH, segment LJ goes all the way through JH, segment JH, and segment KI. And those are your 4. Anything involving G is not going to be a chord, because G is not an endpoint that shows up on the actual circle. It's the center of the circle, but that's about it. Okay. If they ask you to identify the diameters, our diameters here would be Ki and JH, because they are chords that go through the center of the circle. All right. Now you might get a question on a test that's going to ask you about secants. So be prepared to understand the definition of a secant and a tangent for your test. Okay. Question number 12. Plans for a new community include a rectangular park that has a perimeter of 600 feet. Dione creates a model. Okay, so let's get our actual park and then our model park, so we at least are seeing a comparison. Our rectangular park has a perimeter of 600 feet. That feet is going to be important. Okay, perimeter equals 600 feet. Because they're going to ask my perimeter of my model in inches. They have a similarity ratio of 1 to 200. And that's going to be our model to our park. Okay, our model to our park. has a scale factor of 1 to 200. What's the perimeter of the model in inches? So if we're model over park, then we're going to be model over park. Okay? So what we're going to get is essentially cross-multiplying 200x equals 600. Okay, and when we divide by 200 to solve for x, okay, we're getting x equals 3. But what we're actually getting is x equals 3 feet, because this is foot to foot. But the question is in inches, so I need to take 3 times 12 inches, because there's 12 inches in a foot, to get the number of inches. So x actually has a perimeter, or smaller model actually has a perimeter of 36 inches. And that's a really easy way to get caught, because they will probably have 3 in the answer key, in the answer, or as one of the options. All right, number 13. 13 is another similarity question. Let me see if I get flipped over. And 13. Because what they're doing here is, based upon the reading up above, is that they're creating a right angle across the river, because they're walking straight along the edge of it. They're trying to make it parallel with the river, so it's perpendicular with the river itself. And then they tell me about this turn here, turning at a right angle. So I know that those two angles are the same. And I know that this angle should be the same as this, because we're making sure that John stands in the middle. So I've got angle-angle similarity, and my side lengths are proportional. Not congruent, but proportional. So I'm just putting those tick marks so we see a comparison here. So if we're going to do, let's say we're doing the river triangle over our walked out triangle, then we're going to get x over our corresponding 30, and our big triangle 20 over the corresponding 10. So we're going to take 30 times 20, which is 600. 600 divided by 10 is going to be 60 feet across. And that's what my answer should be. What is the distance from X to the rock, as we're looking at those triangles? All right, let's come down to 14. 14 is based upon inscribed angles and intercepted arcs. That's found there in lesson 47, circles and inscribed angles. And one of the things that we learned in there is that an inscribed angle that intercepts a diameter or a semicircle will be a right angle, because one of the things we learned about inscribed angle is that they are always going to be half their intercepted arc, and that the intercepted arc is always going to be twice the inscribed angle. So a diameter will always split a circle into 2, and if a circle has 360 degrees and I divide that by 2, I'm going to get 180 degrees. So this is 180 degrees, and because we understand that inscribed angles are half the intercepted arc, we know that 2x plus 5 has to be equal to 90 degrees, not 180. And then we just do what we do to solve for x. We isolate it. So we get 2x equals 85. We divide by 2, and x equals 42.5 degrees. So let me double check that. 42.5 degrees. Okay? All right. Number 15, talking about three-dimensional solids. You could look at this and see quite a bit about it. Identify the bases. The bases of a prism are the parallel sides. Okay, so in this case, it really comes down to counting the number of sides that it has. And if I'm not wrong, this is a nonagon. It has 9 sides as I count around it. Identify the bases and faces of the polyhedron. So it's actually a nonagonal prism. Okay, the bases are 2 nonagons. The faces are 9 rectangles. Okay, so bases, 2 nonagons. Which is those rectangles that come across out here, are 9 rectangles. in the faces of any prism should be rectangles. Okay? All right, 16. 16 is one that we have to work from right to left, and we have to use what we know about isosceles triangles. Isosceles triangles have vertex angles, they have base angles that are congruent. The base angles are going to be the angles that are opposite to the congruent sides. So if I look at triangle BDC, this guy right here, I'm going to see this. So if this is 40 right here, then this has to be 40 degrees right here because my base angles are congruent. Now, what I end up, because I'm trying to find this little angle right here, I'm going to work my way across to this triangle right here, triangle ABD. And the first thing I'm going to use is I'm going to try to find out what the vertex angle of triangle ABD is. Because these angles are supplementary pairs, then I can take 180 minus 40, and that's going to get me 140 degrees. So I know that this is 140. And because they're showing me congruent sides there, I know that triangle ABD is also isosceles, so its base angles, angles opposite my congruent sides, are also congruent to each other. So if I have 180 degrees and I subtract 140, I'm left with only 40 degrees for those two angles to share equally. So I have to take 40 divided by 2, and they each have 20 degrees. And if I go back up to what this says here, it says that AO, that length right there, let's use a different color. AO is an angle bisector, which means it's taking this angle right here and dividing it in 2. So what we're actually needing is we're needing 20 divided by 2, and that final angle BAO is only half 20 degrees, so it's actually 10 degrees. Okay, angle BAO is 10 degrees. That is from lesson 51, properties of isosceles and equilateral triangles. Okay. All right, number 17. 17 is lesson 53, 45, 45, 90 right triangles. We learned that 45, 45, 90 triangles are isosceles. So the exact reverse truth or converse truth of what we saw in number 16, where we knew the 45, 45s, or, actually even the same thing that we saw. If these are congruent, then their sides opposite have to be congruent, which is going to make them, if they tell me it's a 45, 45, 90, then these have to be 45, and that has to be 90. Now, the biggest mistake that people make with this is assuming that the hypotenuse of this triangle is 16. It's not. The length here, the width of the house is 16, but the hypotenuse actually goes out a further half meter on either end of the house. Well, a half meter and a half meter is going to be a whole meter, so the actual hypotenuse of the triangle is actually 17. And if you'll remember in our 45, 45, 90 triangles, the relationship was x to x to x radical 2. So what we're seeing is that x radical 2, in order to find L, in this case is 17. So 17 is equal to x radical 2. If I want to find out what L, or x here, I have to divide by radical 2 over radical 2. Now, if they'd asked me for simplified radical form, I would obviously rationalize the denominator and I'd get 17 radical 2 over 2. But here they want it to the nearest meter, so we're going to take our calculator and we're going to type it in. 17 divided by radical 2, and we're going to get 12.02, but because they want to the nearest whole meter, it's just 12 meters. 12 meters. Okay? Again, that's the work that we need to show. We cannot come up with these answers out of nowhere. Okay? 18, I'm going to try to do relatively quickly. It says in triangle ABC, show that mid-segment KL is parallel to AB and KL is 1/2 of AB. The first thing that they are going to do here in the answers is actually find out the coordinates of L. Now, it's easy to see the coordinates of L just by looking at it. We know that it's going to be 0, 0, but they're actually going to ask us to check it by putting it against the midpoint formula. So I'm going to take the midpoint formula that we saw earlier in this review, and I'm going to apply C and B coordinates to it. So -4 plus 4 divided by 2, and 2 plus -2 divided by 2. -4 plus 4 is 0. 0 divided by 2 is 0. Okay. And 2 plus -2 is 0. 0 divided by 2 is 0. So we know that L equals 0, 0. And that's going to be the first part of what we need to find. Okay. All right. The next thing they want is that we want to prove that KL is parallel to AB. In how we prove that lines are parallels if they have the same slope. Slope is rise over run. So we look at our rise. Okay. It goes up 1. It goes over 4. So I have a slope there of 1/4. A goes up 2 over 8. You can count that. Up 2 over 8, 2/8 reduces to 1/4. Now we can use our coordinate locations too. Coordinate locations in order to find this are y2 minus y1 over x2 minus x1. And so you could have shown, hey, I know the coordinates to K and L, plug those into y2, y1, x2, x1, and get your slope that way. I prefer this. It's a lot quicker, a lot more direct, easier to see. So they both have a slope of 1/4. So in the answers, I'm looking for slope of 1/4, slope of 1/4. The next thing is that we want to see that KL is half, 1/2 AB, and what they're talking about there is distance. Okay, well, I could still use the Pythagorean theorem for that because it is having me create right triangles where my line segments I'm solving for are the hypotenuse. So I'm winding up on KL, doing 1 squared plus 4 squared equals C squared. 1 squared is 1, 14 squared is 16. So I'm getting 17 equals C squared, square root of 17 equals C. Okay, so KL is square root of 17. All right, now I do the same thing with AB. Okay, in AB, it goes up 2 over 8. So 2 squared plus 8 squared equals C squared. We've got 4 plus 64 equals C squared. We've got 68 equals C squared. So we need to square root this and simplify the radical 68. All right, well, that's going to be 2 and 34. That's going to be 2 and 17. 17 is a prime number that won't reduce. So we're going to end up taking the 2 out, leaving 17 in the radical. Well, wouldn't you know it, 2 radical 17 is twice radical 17, so KL is 1/2 of AB. You need to see the radical 17 and a 2 radical 17. Show me the Pythagorean theorem or the distance formula on how you got those numbers, so I know that they didn't come out of nowhere. Okay, I know you're going to use your calculator. Show me the calculations. Okay, write them down. All right, number 19 is really more about being able to read a 2-column proof and show how the information goes into a paragraph proof. Normally, every sentence should include a statement and a reason. Sometimes a sentence will include 2 statements and reasons. So as I look through here, you should see that, you know, this first part here is going to match up with that first sentence. And they are going to go in order from top to bottom. Is going to be sentence after sentence. Okay, so they won't come in out of order. So what we should see is that if this has angle 1 and angle 2 are supplementary, okay, I'm seeing that right here. So the missing part for this is actually the same side interior angles theorem. Okay, by the same side interior angles theorem, angle 1 and angle 2 are supplementary. This is really just more about being able to read and follow a 2-column proof and being able to interject that information into a paragraph proof. Sorry. I can come down here to my next spot where it says angle 2, and by this measure angle 1 equals measure angle 2. Okay, well, notice that they've already included the information from statement 3. So I'm actually looking for the reason for this right here. Well, the reason for that is the definition of congruent angles. Okay, so that's 2. All right, and we can come all the way down to number 3 because they're stopping with number 3. By this, therefore this, by the definition of a right angle. Well, that's my definition of a right angle. Don't get it confused with this one right here. Okay, we've already got that information in here. Okay, right angle by definition. Okay, they've already got that there. So what we want is we want this to go in right there. Okay, so that is 1, 2, 3. If you want a place to look up some two-column proofs, paragraph proofs, those types of things, okay, that is going to be lesson 31, flowchart to paragraph proofs. All right, let's come down. Let's do at least one more question. Okay, question number 20. Okay, it's talking about a centroid here. Okay, altitudes, medians of triangles. Okay, what they give us kind of some extra information in the whole telling me that CO is 15. Okay, what they do tell me is that these are medians. Okay, that are drawn back to opposite vertices. And if I go back and I look in lesson 32, right, it's going to tell me about where the intersection of those medians in that centroid. And it's going to tell me that from the centroid to a vertex is 1/2 the total distance of the median. All right, so if they tell me that BY is 16.5, then the distance of BO is only going to be 2/3 of that. And whenever I calculate that, I get 11. Okay, and you can plug that in your own calculator and get that answer. BO equals 11, but I need to show that work right there. Okay, maybe we've got enough time for question number 21. Let's try that. We've seen this. This is acute, obtuse, or right. So if you remember, we had 3 different formulas to determine acute, obtuse, or right. Right is obviously a squared plus b squared equals c squared. Obtuse is a squared plus b squared is less than c squared, where my hypotenuse side, okay, my third side is big, too big to be right. And then my last one is a squared plus b squared is greater than my c squared. The sum of the square of those is greater than just that third side. So the first thing we want to do is identify the largest side. All right, and then we're going to set everything else up. So 5 squared plus 12 squared equals 13 squared, and we solve to see if they're equal, less than, or greater than. So 5 squared is 25, 12 squared is 144, 13 squared is 169. 25 plus 144 equals 169, and because these things equal each other all the way across, we know that we are dealing with a right triangle. If 13 squared had been less than the value of the other two sides, then we would have called it acute. If it had been greater than the sum of the other two squared, we would have called it obtuse. All right, that's probably a good spot to stop for this